Okay, so I'm going to show you a couple calculated tricks, the TI-84, for finding area under the standard normal distribution curve or any distribution curve, and then vice versa. So finding area or like vice versa, known area, find the value. Those are really the situations coming up in the week. This semester, what is it, week 8? But this has to do with standard normal distribution, regular normal distribution, and then, you know, central limit theorem applies here too. So you can use this for like all of that. So if you have your curve and you want to find area, so you know, obviously both directions of the curve go to negative infinity and positive infinity. This is my standard normal distribution curve where the mean is 0 and the standard deviation is 1. And I have a z-score over here on the left tail of negative 0.23, and I want to find the area to the left of it. So regardless of how the question is asked, you know, you're finding the area, right? Now I want you to realize that to the left, which is negative infinity, as a z-score, we don't necessarily use negative infinity or positive infinity, you know, on the graphing calculator. So what we would use to represent over here in the left tail as if it were like negative infinity, you just use a large negative number. So I've seen people use like -1 e like 99, and then over here in the positive tail 1 e 99. Oh, sorry. So a large negative number, a large positive number to kind of represent negative infinity and positive infinity, because we know the bulk of the stuff is like, you know, here. And as we get into the tails really, really far, most of the area is not really there. So we represent negative infinity here and positive infinity with these things on the graphing calculator. That's like scientific notation, -1 times 10 to the 99 or 1 times 10 to the 99. So just like binomial distribution, you know, we're doing normal distribution. So you're going on top of vars for distribution. So second vars again. You know, we saw binomial PDF and CDF down here. Now it's all about normal CDF or inverse norm. That's what we're using for this week coming up. Normal CDF or inverse norm. So we use normal CDF when we want the area. So let's say I want to know what this area is to the left of this z-score on a standard normal distribution curve. I'm going to go to normal CDF. My lower bound, it's already in there for me. it bounds your area for you. And the values that you place here are the values on the horizontal scale. So if I want this area to the left of the z-score, I'm going to bound it with like a left, you know, value, which this is like a leftmost z-score, which is representing negative infinity, which is already in my calculator, but I'll show you how to do it. And then my upper bound would be the z-score. So between this and this is the area that I want. That's what this is asking me for. What's the lower and upper bound of the area that you want? And then you tell it the mean and standard deviation. So really this is probably all I have to show you, because you can always change these values depending on the distribution that you have. So your lower would be -1. This is your negative, you know, negative sign here. Don't use minus sign for negative. Always use the negative. So -1, your E, to represent that E. On top of the comma here is EE. That's like your scientific notation. So you're going to go second and comma to bring that up, and 99. So this is -1 E99, -1 times 10 to the 99, a very, very small number representing my negative infinity. My upper bound for this particular scenario would be this z-score of negative, see the negative here, 0.23. And then my mean, since it's standard normal distribution, is 0. My standard deviation is 1. Leave that and then enter. And, you know, if the calculator doesn't directly ask you for the lower bound, upper bound, mean, and standard deviation, that's the order in which it comes here. Normal CDF, lower bound, comma, upper bound, comma, mean, comma, standard deviation, and then enter again. So it tells me what that area is. So really, you know, if I'm not on a standard normal distribution curve, you know, not much is changing. So let's do this situation. Let's say that I want the area to the right of this value, 72, for whatever distribution this represents. Again, I want the area, so I'm using normal CDF, and I find normal CDF over here in distribution on second vars. And so normal CDF. Then my lower bound here, because I'm going on the right, the lower bound of the area is 72. And my upper bound would be like positive infinity, which we represent as +1, and then second, comma, to pull up that E to represent your scientific notation, and then 99, 1 times 10 to the 99. Then I'm changing my mean to 50, and my standard deviation 12, and that's it. Enter, enter, and it does it. Much better than using the tables. I feel like it's much faster. So if you have like central limit theorem where you're finding, you know, probability, or you're finding area for a situation where you're given, you know, you have to change your mean for the sums, average of the sums, or average of the mean of the averages, or standard deviation of the averages. Really, you just have to change this part, the last two values here, for whatever distribution you're on if you're looking for an area. If you're going in the reverse, where you know the area and you want the value, you're still going to go to distribution, second vars, to pull that up. But now you're using what's called inverse norm, this INV-NORM, which is number 3. That's what you're using. When I press enter, this comes up. Now, here's the thing about inverse norm. So I think because we're using the TI-84 plus, everybody should have this option here to say where the area is, like which tail. Is it to the left of the value? Is it to the right? Or is it between two values? But like older calculators, if they don't have this option, it's automatically area to the left. So sometimes what I do is I always leave it as area to the left. I mean, I think if you use the tables, it's the same idea, right? It's always the area to the left. So if this is not an option, which it's not for older calculators, but it might be for all of ours, because I think all our students are supposed to be using TI-84 pluses. So they should have this option, but if they don't, it's automatically area to the left that you have to input here. So it's asking me for the area that I know, and I'm just going to leave it as area to the left, which is what this is. So 0.02. 23. And then on a standard normal distribution curve, I can change the mean and standard deviation to whatever it is, depending on whatever situation I have, whatever distribution. I'm going to leave the tail to the left because the area is in my left tail. And then I paste. Same order, inverse norm. This is always area. And in this particular case, it represents the area to the left, and then the mean and the standard deviation. And it tells me that that z-score would be negative 1.995, or however we want to round. I'm going to show you 2 ways to do area to the right, only because, like I said, not everybody might have the option where you could tell it where the area is. So for those people that don't have that option, which again, I'm assuming everybody does because of the TI-84 plus is, you know, fancy new calculator. They're supposed to get that one, right? So, but second vars to pull up distribution again, and I'm going to go back to inverse norm, and I'm going to put this area 0.17, and I'm going to change my mean to 50 because I'm changing this distribution. Their average is 50 and the standard deviation is 12. And again, if you're using the central limit theorem, you could just change that to whatever mean and standard deviation you are dealing with for that particular distribution. Now, being that I put the direct area here, 0.17, and it's the area in the right tail, I'm going to go over here and highlight right. So I'm going to change that option. So scroll with your arrows to the right and then press enter so it's highlighted, and then press paste. So you'll see this is the area and it's in the right tail, and this is the mean and the standard deviation of that particular distribution, and that's the value that X represents. So again, we know the area, we're finding the value. Now, the only other thing, I'm sure you guys are cool with this, inverse norm, like if they don't have this option, oops, then it's automatically area to the left, and this is when I would do the 1 minus 0.17. But I should get the same thing, right? Because I'm saying this is the area that represents the area to the left, which is obviously the complement of this, 1 minus the 0.17. and I'll get the same thing, right? So the only reason I showed that last one is because, like I said, depending on the calculator they have, which all TI-84s should have the option to choose where the area is, right, left, between. But if it doesn't, then it's automatically area to the left, and that's when they would do that 1 minus. So it just depends on the calculator. But other than that, that's it, you know. Normal CDF, if I'm using, or if I want to find the area, and then I bound it, lower bound, upper bound, and then tell it, right? Tell it whatever the distribution you're on, whatever the mean and standard deviation is. And then if I want to find the value and I know the area, that's when I use the inverse norm. And then again, same thing, right? You tell it area, you can tell it where the area is. So I'm gonna show you again, second bars. Normal CDF is what I want if I want the area. An inverse norm, calculator. There you go. My inverse norm is, you know, when I know the area, and then you can tell it where the area is located. And then just change the mean and standard deviation for whatever situation you have. And that should be all.